All right, continuing 9.1, we're going to write an explicit formula for this sequence, and then we're going to find the 20th term. So writing explicit and recursive formulas are all about figuring out your patterns in your sequence of numbers. So you might try seeing how much you're adding, how much you're multiplying by, trying different things to try and figure out what the pattern is. With this one, what we notice in the pattern, hopefully we would notice this if we stared at it long enough. Sometimes the patterns are harder to see, and I would consider this to be kind of one of those. Hopefully you'll agree with me that each one of these is one less than a perfect square. So if I add 1 to each one of these, I'm going to get a perfect square, right? 1, 2 squared, 3 squared, 4 squared, 5 squared. So here I have each one of these is 1 away from being a perfect square. So specifically, the first term is 1 squared minus 1, right? The second term is 2 squared minus 1. The third term is 3 squared minus 1. And the fourth term is 4 squared minus 1. The fifth term is 5 squared minus 1. So hopefully you see where I'm going with this with my explicit formula. If I want to find any term, I just need to take its term number, square it, and subtract 1. And that's really all there is to this formula. So once you've figured out the pattern, this becomes pretty straightforward. I think the hardest part of this problem is seeing that pattern, seeing that these are perfect. These are all 1 less than a perfect square, I think is the trick to this particular problem. So now we're going to find term 20. So A20 is going to be 20 squared minus 1. So 20 squared is 400. 400 minus 1 is 399. So A20 is going to be 399. All right, let me know if you have any questions, and I'll see you in the next video.